Hello students, so we are doing revision. Okay, so this question is from relations and functions. Okay, this can be asked for 3 marks or 4 marks. Okay, so here the function is defined from natural numbers to natural numbers. Okay, it is defined as f of x equal to x square plus x plus 1, and we have to show that it is 1 but not onto. Okay, 1 is also called injective and onto is called surjective. Okay, whenever both are true, 1 and onto, we call it bijective. Okay, so first you should know what is 1. So let's just quickly revise. 1 means elements from this set are related to another set. Okay, only one element is related to one. This is called 1. And onto means every y in this set has a pre-image. Okay, that is for all y belonging to say B, okay, has a x, there exists a x belonging to A such that y is equal to f of x. Okay, so every element in this B should have a pre-image. Then we call it as onto. Okay, let's prove 1. So to prove 1, you have to take two elements from our A set, that is our natural number set. Okay, let's say x1 and x2 belongs to n. Okay, so we have to take, starting from f of x1 equal to f of x2, we have to show x1 equal to x2. So we have to write our x1 plus 1 . Okay, so this one you can cancel, then x1 square minus x2 square plus x1 minus x2 equal to 0. This is of the form a square minus b square, so I can write x1 minus x2, x1 plus x2 plus x1 minus x2 equal to 0. Okay, so you can take common x1 minus x2. So inside you will get x1 plus x2 and this 1. Okay, now either this term is equal to 0 or this term is equal to 0. So x1 minus x2 is equal to 0 or x1 plus x2 plus 1 is equal to 0. Now this cannot be equal to 0 because x1 x2 lies in the natural numbers. So natural numbers can't be negative. Okay, to come this answer as 0, there has to be some 0 and minus 1, right? So negative numbers are not there in natural numbers. So we can write that x1 plus x2 plus 1 is not equal to 0 as x1 x2 belongs to natural numbers. So the possibility remains is this. So this shows x1 is equal to x2. So we have proved that f is 1. Okay, now let's prove f to be onto. Now onto, we have to take some y. Okay, so let's say some y belonging to n we are taking such that there exists x belonging to n. Okay, such that we have y equal to f of x. Okay, so f of x is our x square plus x plus 1. Okay, so we can write this as x square plus x plus 1 minus y equal to 0. Okay, so this will be plus 1 minus y equal to 0. So this is of the form a square plus 2ab plus b square. Okay, so we can use here our discriminant thing, that is you have to use quadratic formula. So x equal to minus b plus or minus root of b square minus 4 into A into C upon 2A. So 2 into 1. Okay. So this will be minus 1 plus or minus root of 1 minus 4 plus y upon 2. So y minus 3 upon 2. Okay. So yeah. So this is our x. Now you have to find values of x, okay, such that if you take here y, say 1, so this will go, if you take y, suppose y is 1, okay, you will get x equal to minus 1 plus or minus root of 2, 1 minus 3 is minus 2 upon 2. This is a complex number, right? This does not belongs to n. Okay. So, and y belongs to n. Y is a number from n. Okay. So, for y equal to 1, there does not exist x which belongs to n. So, this says that f is not onto. Okay, let's prove this. Okay, let S be a set of points in a plane and R be a relation. Okay, and relation is defined as set of all points a comma b such that distance between a and b is less than 2. Okay, so here you have to prove that R is an equivalence relation. Okay, so to prove equivalence, first you have to prove it is reflexive, symmetric and transitive, right? So first we have to prove reflexive. Reflexive means you have to take the same points, that is, say, let's say A belongs to the set of points. Okay, then the distance between A and A is obviously it is 0, right? We are taking the same points. So this is less than 2 and this proves that A comma A belongs to R. So we have R is reflexive, correct? So to prove reflexive, you have to take one point or one set from the set which is given, and then you have to take the condition, and that condition you have to prove it to be equal. Okay, and so this is reflexive. Second is symmetric. So for symmetric you have to take, let's say, A comma B belongs to R. This is one element I have taken from R. So this implies distance between A comma B, A and B is less than 2. So if we take distance from B to A, this will be also same, right? So this implies that B comma A belongs to R, and this implies R is symmetric. Okay. Then third we have to prove transitive. Transitive means you have to take two elements from R, that is A comma B and B comma C, and then you have to prove A comma C belongs to R. Okay. So let A comma B belongs to R and B comma C belongs to R. Okay, so this shows distance between AB is less than 2 and distance between BC is less than 2. Now for here, if you write in general, that is directly if you write distance between A and C is less than 2, that is not true. So because if we take any example, say this you have to prove by example because here numbers are involved. So distance between, let's say distance between A and B is our less than 2, means I'm taking it to be equal to some 1.5. okay, and distance between B and C I'm taking it to be 1.7. okay, so both are less than 2. Now if you take distance between A and C, okay, now we are considering these points to be collinear, that is they are on the same line. okay, A, B and C. So distance between A and C, okay, it will be addition of this two, 1.5 plus 1.7. So it is 3.2, which is not less than 2, which is greater than 2. So our property fails here. Okay, so this is not true. So we can say that A comma C does not belong to R, and this shows that it is not transitive. It is not transitive. So this is not an equivalence relation. Okay. In previous question I have taken this 4 and minus 4y, right? So this will be 4y. Okay, this is the mistake I have done. So this is 4y. Okay, so for y equal to 1 it is possible. For y equal to for y equal to 1, this will be 1. For y equal to 2, it will be 5. So you can take here example 2. Okay, I'll write here x equal to minus 1 plus or minus root of 4 to the 8, 8 minus 3, 5. So this is irrational number, so it does not belongs to n. Okay, so this is the